Okay, temperature, heat, and the first law of thermodynamics. So, if two objects are in thermal equilibrium with each other, that means that they cannot be at different temperatures. So, they must be at the same temperature. And then we move on to number two. When two gases separated in a thermal wall are in a thermal equilibrium with each other, only when their temperatures are only their temperatures must be the same one as the first one. A balloon is filled with cold air and placed in a warm room. It is not in thermal equilibrium with the air of the room until it stops expanding. It stops expanding. That's C. The answer is C. Suppose object C is in thermal equilibrium with object B, and the zeroth law says that A is thermal equilibrium with B. I saw this one in the test. The zeroth law of thermodynamics allows us to define temperature. If the zeroth law of thermodynamics were not valid, which one of the following could not be considered a property of an object? Temperature. The international standard thermometer is kept nowhere. There is none. International standard thermometer is not kept anywhere. When constructing a thermometer, it is necessary to use a substance that undergoes some change when heated or cooled. The threshold point of a substance is that point for which temperature and pressure are such that solid, liquid, and vapor are all in equilibrium. So the answer is D. Constant volume gas thermometers using different gases all indicate nearly the same temperature when in contact with the same object if the particle concentration are all extremely small. E. A constant volume gas thermometer is used to measure the temperature of an object when the thermometer is in contact with water at its threshold point. The pressure in the thermometer is 8.50 times 10 to the power 4 pascals. When it is in contact with the object, the pressure is 9.650 times 10 to the power 4 pascals. The temperature of the object is 310 Kelvin. When LCD and constant gas volume thermometer is in thermal contact with water at its threshold point, the temperature is 6.30 times 10 to the power 4 pascals. For this thermometer, a Kelvin corresponds to a change in pressure is about 2.31 times 10 to the power 2 pascals. B is the answer. Okay, the diagram shows four thermometers labeled W, X, Y, Z, W, X, Y, and Z. The freezing and boiling points of water are indicated. Rank the thermometers according to the size of a degree on their scale, smallest to largest. Okay, smallest to largest D. So Rotomaka this one, Z, Rataka this one, Rataka this one. So it's 1, 2, 3, 4. 1, 2, 3, 4. There is a temperature at which the reading on a Kelvin scale is numerically is equal to that on the Fahrenheit scale. Fahrenheit and Kelvin scale agree numerically at a reading of E574,574. Which one of the following statement is true? C is true. Temperature which differed by 10 degrees on the Celsius must differ by 18 degrees on the Fahrenheit scale. A Kelvin thermometer and a Fahrenheit thermometer both give the same reading for a certain sample. The corresponding Celsius temperature is C 301 degrees Celsius. Room temperature is about 20 degrees on the degree Celsius scale. Degrees Celsius. Thermometer indicates a 98.6 degrees Celsius. It may be in a cup of hot tea. The air temperature on a summer day might be about C, which is 25 degrees Celsius. The two metallic strips that constitute some thermostats must differ in coefficient of linear expansion. That's the only one I know. The thin strips of iron and zinc are riveted together to form a bimetallic strip that bends when heated. The iron is on the inside of the bend because B is a lower coefficient of linear expansion, which is B. It is more difficult to measure the coefficient of volume expansion of a liquid than that of a solid because the containing vessel also expands. The Savier's 30-meter steel tape is correct at 68 degrees Fahrenheit. On a hot day, the tape has expanded to 30.01 meters. On that day, the tape indicates a distance of 15.52 meters between 2 points. The true distance between these points is 15.54 meters. The figure below shows a rectangular brass plate at 0 degrees in which there is a cut, a rectangular hole of dimension indicated. If the temperature of the plate is raised to 150 degrees Celsius, both X and Y will increase. The Stanford Linear Accelerator contains hundreds of brass discs tightly fitted into a steel tube. See figure. The coefficient of linear expansion of the brass is 2.00 times 10 to the power 85 per degree Celsius. The system was assembled by cooling the disc in dry ice at 57 degrees Celsius to enable them to just slide into the close-fitting tube. If the diameter of a disc is 80.00 millimeters at 43 degrees, what will be its diameter in the dry ice? It will be 79.84. Yeah.